Welcome to CKAN Insider number 5. My name is Andrew Nette, and today I'm joined by Cherniavskyi. Alexander is a full-stack developer at Link Digital and one of our comprehensive knowledge archive network experts. He's also an important figure in helping to steer the open data ecosystem towards integration with modern AI technologies. At Link Digital, he's been key in helping to design our new Ask AI feature, an AI-powered layer on top of CKAN that lets users query CKAN data portals using natural language. Thanks for joining me today.
Thanks for having me.
Okay. Open data portals have matured significantly over the last decade. Many organisations now operate CKAN instances containing hundreds, if not thousands, of data sets. Yet you've talked in some of your articles about that there's a friction remaining that's here between having data sets on a portal and their discovery and interpretation. What's wrong with the discovery experience on many portals?
There are multiple things wrong, but the most important thing is that the most data portals are built for people who already know what they're looking for. If you are visiting a data portal that has, for example, 1,000 datasets or 10,000 datasets, and you don't know what exactly you are looking for, you have a few keywords, but you can't find a text that represents your keyword. You tried to search and it didn't return any results. So this is sometimes a bit of a lottery when you're trying to find something. And it is especially true for someone who's just a regular person, not someone who works in a government organization, who works in some kind of department that helps maybe with this data, or he's a contributor. A regular person doesn't know anything about the specifics of the data portals. Also, I thought about thousands of data sets, so there is an issue with browsing. For example, you can scroll 100 of data sets, maybe read carefully the title, the description, and maybe map the descriptions with the things you need and find something you are looking for. But if you are looking for something inside thousands of data sets, browsing won't help you. You can't do it. You need a search. And that's when we have created a knowledge assistant that helps you also with the searching things. It understands not the keywords, but the semantic of searching, and it can map the words that are somehow similar. For example, auto, car, mobility, something like that will be similar in one search.
Okay, so can you walk us through how the knowledge assistant or the Ask AI feature works?
Yeah, so without starting a demo right now, I will just say that imagine that you have a data set, and we index this data set, means we read it carefully programmatically and transform it into some kind of a unique fingerprint that this data set has. And when the user uses search, we do the same thing with the user search query. We transform it into a fingerprint, and then we compare those two fingerprints and say that this query search looks like this fingerprint of a data set. And then when we have a result, the same thing works not only with the search, but for example, if you ask a knowledge assistant on the portal, what is this data set about? Or can you find me data set related to this topic? Yeah, the application will do exactly the same. It will just take the query, look into the, let's say, a storage that holds all the information and retrieve the results. I will just share my screen right now. I will just share the entire screen. Can you see my screen?
I can, yes.
So it's always a bit complicated to make a live demo. Like right now, this is my local machine. So everything that is running here will be run on my local machine, my GPU, my CPU. We are not using right now any cloud solutions for the LLMs. We'll probably talk about it later. So I have created 30 datasets. They kind of look like real data, but they were like generated by me. So they do not represent any real information, but I was just trying to follow some kind of common sense. So, for example, you see the school attendance rate and attendance and absenteeism rates in Australian schools. So I'm opening, for example, a chat and ask, what is this data set about? Then here you can see that I have a lot of text, and this is the job that works right now. The speed of this depends on the hardware you have. Basically, the AI stuff is very hardware dependent. So we wrote a code that represents the software, and the hardware part represents my GPU mostly and my CPU. Right now, I'm asking it a question. What is DataSet about? It says the school attendance rate. DataSet provides information about attendance and absenteeism. So you see, there are not a lot of information in there. We are not trying to make up any information, because this is what AI can do if you will ask it to. But let's go there, for example, and say that school attendance rate, Australia, I just tried it before, Queensland, 2019, 2020. And you see there are buttons with improve title on it. I just press improve. And right now I'm trying to ask my assistant to help me with filling the metadata. It's created something, I can edit it, I can create some text, I can give you some kind of a license, maybe generate a source, which will be 100% not true because there is no source inside this. But as you can see, knowledge assistance or SKA helps you with the filling the metadata. It won't help you completely, but let's just imagine that we got everything right. Right now we have a bit of more information inside this data set. And if I will ask the same question again, what this dataset is about, we are now working with more metadata, and this is the main thing you need to focus when you're working with a knowledge assistant. It doesn't make you. It's not magic thing. It's not make your datasets like make more sense by default. You still need to fuse the metadata. You still need to work on it, because a dataset with just a description and a title won't be very helpful, because, as I said, we are not trying to make up things. If you, for example, will take a dataset I have here that is called car ownership, I just took some kind of a data from the open data elsewhere. It holds the real data, as you can see. So it represents, I guess, the households that has a car, and it says what kind of household it is. So if I will ask the same question, what is the data set about? In this case, we have more information, and we also have a resource. We index both data sets and resources. When you have a resource, and usually on a real portal you have a resource, you have more information to work with, and we'll just see it in a few seconds, I guess. Yeah, so as you can see, it has some kind of information about the data set. It knows that it has a resource. CSV contains a lot of rows. It has some information like about important columns inside this data set. And that's it. You just can talk about data on a portal with a knowledge assistant. But it's not all. For example, if you are looking for something, let's say you are looking for police reports, or maybe let's just say police. I have a few data sets on the portal. Let's see. Domestic violence statistics. So I have wrote a query called police, and I see there is only one result returned from search engine. So without a knowledge assistant, there would be only one. There would be only one result. But we are trying to understand what a user is looking for, and we just appending a few more results. In our case, we appended 4 more data sets. So it's one called protection ordered issued, one called domestic violence. So as you can see, all of them somehow related to police or related to some accidents. And this is what the similarity search does. It tries to interpret the meaning of word and more like a similarity of one word to another. And in this case, it's very helpful. And plus, it's very fast. For example, if I write auto, you see, it's very fast. It's not like we just were waiting before when we were talking with the knowledge assistant. In this case, we just working with the indexed or fingerprints created before when we index the whole portal. And now we can operate with this data basically like we did before with the SOAR. It's not very interruptive. And as I showed before, you have a feature to append some kind of information or improve the description, improve the text. I find it very helpful, to be honest. Sometimes you just need a Kickstarter to start writing something. If you add something here, for example, 2019, we are just improve it not basic on this specific field. We are using everything we have. So if you will improve something here by manually, you can generate something more meaningful here with the generative AI.
That's a great overview of the basic functionality there.
Yeah.
I suppose one of the questions is that, I mean, data security or data sovereignty, as people call it, is a major concern for organisations as well as government agencies. How does the Ask AI feature address this sort of data security question?
So I've mentioned before that right now I'm running on my local machine. So everything you see, all the information is not leaving my local network, as you would say. So we have providers. We can use different providers inside the knowledge assistance. By default, we are using the Ollama models. Those models are local. So I'm running it on my machine, but we can plug different providers. We have implemented the support only for OpenAI right now, but we want to look at the client's response and what they need. So it's totally doable to create a provider for different cloud solutions like Anthropic, for example. This is very important for, as I think, for the data sovereignty when you understand that all your information stays inside your local network. And for example, the vector database also lives on your environment because we are using an extension for the Postgres database. So the Postgres database is a vector storage. So even this step is also stays on your local machine. When you create those so-called fingerprints, you use a local model, small language model. Then you store it in the local database environment. And then when you, for example, asking something about the datasets or searching datasets, we are using CKAN permission labels. This is a second way to handle the permissions on a portal. Each dataset has its permission labels. If, for example, if it's a public dataset, it will have a permission label called public. If it's dataset not a public but private, it will have a private permission label and permission label that says that only, for example, sysadmins can use it or only members of an organization can use it. And when user asks a question or search something, we calculate the permission label for this specific user. So even here, we are not showing any results that this specific user shouldn't see. So this, I guess, 3 points are what makes it private.
Okay, now that you've shared one CKAN instance that uses Ollama or your local database, could you demonstrate another portal that shows a real-life scenario that's sitting on CKAN 2.11?
Okay, let me share my screen again. Yeah, can you see
Yep.
a CKAN data portal?
Yep.
So this data portal uses real data. I must say that the previous one that I have shown was on 2.11.4, the local one, and this one is uses the CKAN master, so it's very close to the 2.12 that we will release soon. So yeah, it's a more modern version of a CKAN. Here we have different datasets that were harvested from an open data portal source.coop. I don't know, let me show you something on the real data. For example, we have this dataset with a PDF resource.
Yep.
And for example, I can open this resource. We see that there is some kind of a data inside.
Yeah.
And we can, for example, say, make a summary of the documentation PDF resource. And I either can read the resource myself with the PDF view, or just can ask AI about the summary. Yeah, so it has some information about the content of this PDF file, some kind of individual fields, blah, 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 some imagery, etc. So it works with the PDF files, but we can do it, for example, with the CSV files. Let's say, for example, you want to give me a summary of this dataset. So this dataset contains a CSV file and some metadata related to the dataset. Yeah, we have some information about the content, the format, the organization, some text. If you have more metadata, the response will be more complete and comprehensive. And for example, because this is a CSV file, we can check the table preview. For example, we can do something like, can you build me a line chart for this resource that represents, let's say, water level change over date time. Just picking those fields from here. Over date time aggregated by months. So here we are asking the assistant to build a chart that uses real data. And hopefully, yeah, it says it analyzes the monthly and average water levels from October to March 2026, and we have some kind of a chart. We can download the chart as an image, or we can download it, in this case, CSV data that represents the chart data.
Okay. Alexander, thanks very much for joining us, and thanks all of you for watching CKAN Insider. If you'd like to learn more about Ask AI, reach out to us at linkdigital.com.au. And thanks very much.
Thanks, bye.